What's going on, my dudes? This is Mr. Gardner, and this is Math Time with Mr. G. Today we're going to start talking about normal curves. Normal curves is our expectation of what's going to happen. So the most expected thing that's going to happen is going to be our average, or a mean. And that's this middle line right here. Some people are going to score below average, but as we get closer and closer to average, more and more people are going to score that amount. And then people above average, less and less people are going to score that amount. Then we want to find out how normal people are. And this is where standard deviation comes into play. Standard deviation is saying, hey, if a C in a class is normal, am I within normal if I don't score a C? So one standard deviation away means you're not average. You're slightly above average or slightly below average, but you're still in that normal range where it wouldn't freak a teacher out. So if you got a B minus or a D plus on a test, teachers are going to freak out about that grade because you're super close to being average. But if you score another standard deviation away, so this is an equal amount away, let's say you score an A minus or an F, teachers are going to pay attention. Either A minus, hey, is this student super bright and I need to push them? Or this student got an F, what do I need to do to help them? But if you're 3 standard deviations away, so 1, 2, 3, an A plus, you are going to be way outside the norm, and it's going to tell a teacher, hey, maybe this student's too bright for my class, maybe they need to go into a higher class. Or if they get an F minus, hey, maybe this class is too hard for them, maybe we need to talk about them going to a different math class. So C is average, 1 standard deviation is normal, 2 standard deviations, you're starting to become less and less normal, but it's not weird. And if you come 3 standard deviations away, we're starting to have concerns. Okay, if you are 1 standard deviation away, we are going to say that 68% of people fit in this window. So 68% of people are going to score somewhere between D plus and a B minus. If you are 2 standard deviations away in either direction, we're going to say that that is 97% of people. So 97% of people are A minus to F range, somewhere in there. So most students are going to fit in here. That means that to be 3 standard deviations away and be in this A plus range, or 3 standard deviations away, be in an F minus range, is super, super rare, because almost no one's in that range. To be outside that range, I mean. Because everyone inside that range is going to be 99.7% of people. So to be outside 3 standard deviations, super, super rare. So to find standard deviation, we have to talk about a lot of the different symbols that we're going to use. If I say X, this is going to reference to my data. So I ask someone how much money they have in their pocket. Their answer is going to be data. X bar is my mean. So I collect all my data, I add them together, subtract by how much I have. X bar is my mean. This is my summation symbol. That means I take all of my data and I add it together. That's what summation means. Add it all together. N minus 1. This means how many pieces of data I have. And then I subtract 1. S is going to be my standard deviation. And that's how far from normal. And remember, to be 1 standard deviation is 68% of people fit in that window. To be 2 standard deviations and in, it's going to be 97% of people. And if you're 3 standard deviations away and in, that's 99.7% of people. And our last one is going to be this O shape squared, and this is going to refer to variance. And then just a quick reminder, range is how far is the data. So again, I asked people how much money they have on them. One person says $10, one person says $5. The range is me subtracting those and saying there's 5 data points apart. Variance is how far with consideration outliers. So maybe this 10 is super far outside and we need to consider that. And it also says how far to predict second study. So I do a study, I interview 2 people and I say, hey, they're 5 apart. Someone else does a study and they're 20 and 1 and they have 19 away. Well, who's right, 5 or 19? Variance says we can predict who is right and how far away we are from being right. So let's say I interviewed 6 people and asked them how much money was in their pocket. My next thing I'm going to do is I'm going to find the means. I'm going to add all these up, divide it by 6, and I find out that it's 4.2. Next thing I want to do is find my MAD. Again, this is us subtracting these and then doing the absolute value of it, and I get these. Now that I have my MAD, we can look at our variance equation. Our variance equation is variance is equal to the summation of x minus x bar squared over n minus 1. So it looks scary at first, but let's look at what we've already done. We already collected data, so there's our x. We already subtracted our average, that's x bar. So this is just our MAD. So the next thing we just have to find is MAD squared. We have found our MAD squared. That was just taking all these numbers and squaring them. I have to summate them. That means add them all together. Now that I have my summation of my MAD, I just have to divide it by n minus 1. I have 6 things of data, so 6 minus 1 gets me 5. So my variance is 1.2. That means if we did this study over and over and over again, we should expect 10 degrees of difference. Mine has 9 if I look at my range. But if I were to look at someone else's data, they should have around 10. So the more and more we do this, the more and more we'll get closer and closer to 10. My standard deviation equation is simply standard deviation is equal to plus or minus the square root of our variance. So from our previous example, our variance was 10.2. So my standard deviation is plus or minus 3.2. Means our average, again, was still 4.2. And 1 standard deviation away is going to be 1 and 7.4. So that means that 68% of people fit between having $1 in their pocket and 7. Now let's compare that to our data. 1 to 7. Well, yeah, 5 of our 6 pieces of data fit in that window. And then if we go out to our second standard deviation, negative 2.2 and 10.6. So that means that, again, 97% of people fit in that window. That means people have either owe $2 or have $10 in their pocket. Well, yeah, that fits all of our data right there. But if we were to continue to 99%, or our third standard deviation, that means that negative 5.4 and 13.8 is going to fit 99% of Americans when I interview them of how much money is in their pocket. They either owe $5 or they have up to $14. So After we find our standard deviation, we just take our mean, add 3.2, or subtract 3.2. I know this is a lot of work, and I know it's a little bit complicated, so if you have any questions, hit me up in the comments section. But other than that, be kind to each other, ask deep questions, and think deeply.